People back to order. We're going to get started with the first session of presentations today. I'd like to introduce the session chair, Simon Hodson. If you were at the cocktail last night on the boat, you know that he's the executive director of CODATA. He's been in that position for about a decade. He's done some pretty interesting things in that time. He was in the OECD Expert Committee on FAIR, right? They wrote a document called Turning FAIR into Reality, and you should Google that and check it out. It's, I think, foundational in the way that FAIR is playing out in Europe. And then, Simon, you were one of the editors of the UNESCO recommendations on open science, right?
So I was the vice chair of the expert advisory group for that recommendation.
Okay.
Yeah. And so that group did a lot of the drafting, and then, of course, it went through the mill of national approvals, and we managed to save most of the text.
Okay. So Simon's mostly a data policy guy, I guess, but understands the importance of metadata and technology and other aspects of that picture that are probably nearer and dear to some of our hearts. And I guess the last thing I would say about Simon is that he's great to work for and with. So, over to you, Simon.
Thank you very much, Arafan. So I don't need to introduce myself anymore. So welcome to session 4. The theme of this session is really fair. And I think all the speakers are going to talk about how we implement the FAIR principles, or how the FAIR principles can be a guide to what we do in official statistics or other forms of data. So whether that's FAIR plus linked open data, that's the theme and the thread which runs through the 4 talks. I'm going to ask each speaker to talk in turn, and then we'll have questions and discussion at the end. And I think that's an easier way to manage the time. And I'll introduce each speaker, not now in series, but as they step up. So perhaps the first speaker could go to the rostrum. Olav ten Bosch is a project manager at Statistics Netherlands with a background in theoretical computer science and a PhD in electrical engineering. He works in data-intense and international standardization projects on statistical open source software, metadata standards, data visualization, data validation, web scraping, and applied subjects such as energy, air quality, and open data. Olav has been a member of various international standardization groups, including SDMX, ESS standards, and a work package lead on new use cases in the European Web Intelligence Network project. And Olav will speak to us about FAIR to be fair, what is missing in official statistics. Olav, the floor is yours. You have 15 minutes.
Thank you, Simon. Yes, a long introduction. So with my colleagues, Edwin de Jonge and Henk Laloli, we made up this title, and it was meant to be a bit of provoking. To be fair, what's missing in official statistics? So we're looking at the official statistics, our job, making good statistics from a fair viewpoint, and we're not always happy, let's say. I'm talking about the official statistics landscape. What is that? That's kind of all the statistics that we produce with all the organizations making official statistics. I take a software perspective on this landscape. I talk a little bit about linked data, really a little bit because of time, and only one slide about the FAIR digital objects, and you probably don't know what's that, but it might be interesting. And so to start with, very simple. I'm from Statistics Netherlands. We have, as many statistical officers, we have a beautiful website designed by communication specialists from top to down, starting with a homepage with themes, and then you can go down to articles, news articles, thematic pages, visualizations. You click down, and you know the data scientist doesn't want it all. They want data. They want data and good metadata. This, in the end, if they find it, then they come into pre-selected tables, and in the end, in the statistical database. And this is pretty much the case for many statistical officers. Somehow we all have a dissemination system with statistical facts. In our case, we have it for a long time already. It's big because we never throw away our data. 2.4 billion statistical facts, active tables, being maintained by all the statisticians. It's publicly available. You can search, select, filter, download. It's not in SDMX, but we will go to SDMX. It has an API, it's OData, one of the few. And there's software around. So that's us. But zooming out to the official statistical landscape, then we are not the only one. And looking at my slides this morning, I realized that I should have put Insee on it, of course. I'm sorry. Completely mistaking what it was taking. Sorry, Frank. Next time I will. So, statistical officers like Denmark, Netherlands, Germany, and Italy all have sometimes similar systems, sometimes different systems. A lot of data, metadata, and high-level content. And we have the international organizations using the same data, or adding data, or improving data. And this all I call the official statistics landscape for this presentation. So on this landscape, I want to take a very different viewpoint, and the viewpoint is the software viewpoint. I'm also one of the authors of the so-called awesome list of official statistics software. What's that? So with all the statistical officers, we do kind of the same. We make statistics. And we do very complicated operations there. There's a lot of methodology involved. And methodologies implemented in R packages, Python, whatever, and open source software. I'm a great fan of open source software. And if you implement it once and use it in many offices, we are very efficient. So to memorize what's there already, we started this awesome list of official statistics software. It's a mouthful. You can find it on awesomeofficialstatistics.org or type it in Google. And actually, it's maintained by the community. Because if someone has something that thinks is interesting for someone else, give me a mail or send something. On the right, you see a picture of the GSBPM, the Generic Statistical Business Process Model. That's something we use in official statistics to design our processes, let's say, and this visualization says where the official, the open source software is around. So that's a sidestep. One of the categories on this list is access to official statistics, and it happens to be the largest category. So this is how it looks, screenshots of the list. You have a badge, whatever, where it's on GitHub, and if you click on it, you are directed directly to the software. So this access to official statistics has over 30 software packages given access to more than 60 data providers on the landscape. Mostly R packages. And these are generated by the data science community around us. So knowing this all on this list, I could do a kind of analysis of what's in this landscape on the software around us and create a matrix based on the documentation. It was a lot of work to read all the documentation, by the way, and created a matrix of all the packages on the list, 38, the data providers, 60 data providers, and the standards being used. And that's quite interesting. Of course, the well-known standards, but not mentioned in this conference yet. JSON-Stat, OData, PCXs, SDMX, and other are visible in this matrix. Well, you see it on a high level, you can click on it. It's, if I maintain the list, and it's being updated as well. And from a high-level viewpoint, you can see that the world in this landscape is divided into, let's say, the ones that support JSON-Stat and PCXs, it's related, and SDMX, the yellow ones. It's almost a disjunct world. And there's only one, and that's us, that have chosen long ago for OData, which was a completely wrong choice if you see this landscape. So we're actually going to move to SDMX as well. I'm happy with that. So this is horizontally. But if you look vertically, then you have this like, okay, so there's software around to access our data and metadata. And some of them are standards-based, the blue ones. They are like they evolved from a standard. And then you support a lot of data providers, both in the PX world and the SDMX world. And some of them are lonely guys in this matrix. They support one data source, but they happen to be very specific for this data source. They might add all kind of features that are not in the standard. So there is a use case for them. And we have another category, like the official statistics aggregator sites. And actually it was mentioned this morning, the IPEM, they have also software around which gives access to harmonized data, survey data, time space, harmonized. And for the economic data, there's also an example. So this is all around us. And we went one step further, looking into the documentation. What does all this software offer? So we identified a number of features, like hiding the endpoint, hiding the dirty details, getting the catalog, what's there in the data source at all. So for discovery. Search, different kind of queries on the endpoint, local caching is a very important feature in many. Getting the cartographic data with the data is a great advantage for making maps. So that's additional features. Registries have been said so much about it. We scored them in a FAIR matrix, and I think we are strong. It's strong on findability, but not so strong on reusability. And there's coming up this idea about, in future, could we, with this community, create one-for-all software that gives access to all the data? Isn't this our duty? Okay. Official statistics and linked data. So I'm now ending the software perspective. We were also very interested in linked data. And I'm still not sure which way to go. Because I'm a fan of linked data. I'm also kind of a fan of SDMX. I'm a fan of many things, actually. I see the use case of everything. So, and my questions are always, what way to go? What's the best to do? So let's look around about the linked data initiative. And I know there are much more than these, but we in the paper, please have a look if you're interested. We said something about the Eurostat activities, but they were already presented for a lot on the left. We have someone been working on a knowledge graph in our organization, in the middle, for about 8 years. And he happened to have modeled all kind of knowledge from experts, statistical experts, within this knowledge graph. Interviews, he grabbed all the data, metadata he could get in the institute. It's actually a very rich source of metadata information. It's now backing up our search engine on the website. So this is something that I didn't know before, but it convinced me about the flexibility of the linked data model and what you can do with it. And one other example I came by is the Scottish linked data vocabularies site. It's completely linked data driven, and there are interesting things to see there from the viewpoint of referenceability and the model. So, looking from a distance to the linked data, as I see it right now here, linked data is about linkability. From an official statistics perspective, we are always, this is our official statistics, please use them, they're good. But linking with communities is something completely different. Within our community, we can talk and do linking among institutes, like Eurostat, we link to Eurostat, you see it on this thing. Outside of the official statistics community, we can link to communities like Wikidata. And this is exactly what my linked data expert did. Another thing he did was to model changes in metadata. There's actually an example here. This is maybe too deep to go in. But linked data, the third bullet here, the Dutch linked data shows modeling complex statistical metadata dependencies. So what he did was a complete historical graph of the Dutch geo changes on municipality level for over 2 centuries. And in the Netherlands, we change the municipalities every year, actually. So you have to know that. So last bullet, I don't know about you, but could the current AI data training hunger, because we are all scraped to the max for data and text. Could linked data be picked up more easily than specific statistics standards? That would be a question. Okay. I mentioned FDOs, which is FAIR Digital Objects. And that's a way to, I don't know, harmonize a lot of standards into some higher level principles. It builds on the FAIR principles, of course. Up to now, I talked about the official statistical landscape. And we use a lot of standards. And we have this layered architecture, high-level content, news, charts, thematics, the metadata registries, the estimates in the statistical database. And we have a restricted area, and this is becoming more important for all our organizations, the microdata that we offer to the scientific community. That's a growing business. And we use different standards. And it was already in the earlier talks about using different ways of referenceability. And if you look at the FAIR principle AI, so using a standardized communication protocol, we use different protocols. Well, in this FDO concept, I think there are two things might be interesting for us. It's kind of PID system, identification system for all your artifacts. Should we think about something that works for all layers, for all types of metadata? I'm dreaming here, I know, but okay, that's... And there's this concept of machine actionability. So there are 3 levels. Machine readable, you can read it by a machine. Machine, I forgot, understandable, good metadata. So a machine actionable, we say what you can do with it. And when I heard about that, and combine it with the software layer I was just describing, I think all the software that the community creates on our official statistics makes it actionable. Just a thought, because I'm at the end, so you can read about all the bullets and you can read the paper. If you're interested, please mail me, whatever, all the feedback, welcome. But my conclusion was, to be more fair, there's work to do on all the perspectives. We are not ready yet at all. And only then we can continue our role of trusted data partner in a future data. I'm going to read it now because I have one minute to go even. So that was my statement. I hope you enjoy, and questions and very much also welcome. And if you want to work with us on this awesome list of official statistics, please like it on GitHub and have a look. Thank you.
Thank you very much, Olav. Awesome. So because we're going to have questions at the end, I would ask, please think of the questions that you have for Olav and note them down so that there's not a sort of a last speaker bias in terms of the questions that are asked, and we'll have that discussion later. So I'll take the opportunity to introduce the next speaker, Anikó. Yes. Just while Frank is changing the presentation. Anikó Mohay works at the metadata department of the Hungarian Central Statistical Office. She graduated from the university with a degree in Library and Information Science and has been working in data management researcher at the Statistical Office since 2022. The goal is to achieve methodological improvement in the fields of data and metadata management standards, open data and linked open data solutions with semantic web and ontologies and data storage technologies. And Anikó will speak to us about modernization of the central meta-information system in accordance with link open data and FAIR principles. So more on the FAIR principles. The floor is yours, Anikó.
Thank you so much, and hi everyone. Thank you for the opportunity. I made this presentation with Zsuzsanna Mar. No, I can't. Step. Sorry. Yes, okay. Okay, I skipped the outline because time is short. The Central Meta-Information System is one of the case system, the office, where we record and collect our metadata. What kind of metadata these structure?
You need to lean closer to the mic.
Yeah. Okay, sorry. Oh, yes. Sorry. So what can... No. Okay. It's good? Yeah. So what kind of metadata can we collect and record in our central meta-information system? Structural and descriptive metadata and control metadata. Who are the users, non-expert users, and external, and we have two big groups, and external users and internal users. Non-expert users, they require simple and concise, easily understandable description. Definition should be in natural language and readily accessible. Expert users, they need a high quality, clear, precisely formulated metadata. Internal users, statisticians need descriptive and structural metadata. IT expert, statistical data production primary require structural and directive metadata to metadata-driven design database and processes. Examples include the description of production database or data warehouse. Software and programs rely on control metadata for input, requiring directive information this purpose. You can see in this image how we categorization of metadata, users and types based on the metadata. Structural metadata are variables and code lists. Descriptive metadata are contents. Control metadata is a code list. The goal of the metadata system is to have all necessary metadata for the data production process described, stored, and maintained one place within the office. The system operates on database basis, where the structure of database table is also described in metadata. Central meta-information system covers the stages of statistical data production, supported by metadata-driven tools. IT tools, the central meta-information system connected to several other systems where additional stages of GSBPM are implemented. In the system, metadata control actually implemented with the aforementioned control metadata. The application system operates a three-tier environment: developer, testing, and production. The application development takes place Windows-based environment. The foundation of central meta-information system is Oracle SQL developer, user interface SQL form. I would like to say a few words about the principles. We want to follow developing the central meta-information system. We aim to implement the principle linked open data, meaning to publish RDF using semantic technology, thereby facilitating discoverability, accessibility, interoperability, and reusability of our data and metadata. The office deciding whether to upgrade our central meta-information system or purchase a new one. We examine the strengths and weaknesses of the system and identify the task for the development. I showed you what is missing, but time is short. I will talk about this later with the solution. Following, I will present how we plan create, provide, store, and manage metadata within the load architecture according to FAIR principles in the system. The current structure may provide good basic for this implementation. First, we examine the weaknesses of the system and the website based of various criteria you will see in the tables, and we determine the task. First, we examine the possibility of interpreting metadata within the metadata system and on the website. In the central meta-information system, numerous metadata can be recorded for our data. Unfortunately, however, responsible parties often fill out the fields for individual entities incompletely. We would like to change this by specifying more mandatory fields. Before implementing the load architecture, we plan to clean and deduplicate the database. We will query and supplement missing data for each entity type before setting mandatory fields. We aim to formalize various entity types and strive for the use of singular form. It's very important to handle the homonyms and synonyms in the system and assign the relationship them. Our long-term goal would be to create thesaurus, ensuring unified terminology. We publish metadata on the website. However, the site is outdated, does not utilize Web 2.0 technology, and not user-friendly. Load is essentially semantic technology that makes the web content understandable for machines. Furthermore, the RDFs, we have opportunity to link the data visualization to display of individual entities, making our data understandable for users. Additional graph visualization makes the relationship between data discoverable. The next investigation was how could link the metadata. Currently, what the relationship we can define between them. Data and metadata converted into different formats. International dictionaries and ontologies are not used. It is important that our data and metadata be available in standardized format on both on the website and in the system. To achieve this is necessary to develop a converter that transforms the generated data and metadata into appropriate format. The essence of the semantic web is the idea that suggests making data stored in the internet, not only a text characters, but also way the machine can understand. The semantic web essentially the realization of load. Currently, the machine readability of metadata is missing. In the next section, I provide solution for this. In the central meta-information systems, there are numerous opportunities to link metadata describing individual entity types. Within those entities, concept can be linked with code list, variables, regulation, although this does not always occur. For example, concept could be used defining variables, and code list as well enabled by function of the central meta-information system. We also examined how accessible and discoverable the metadata are on the website and in the system. In the central meta-information system, individual modules provide the interface for recording the most important metadata. However, this input interface is outdated, it's not user-friendly, the function buttons not work properly, the interface is not responsive, and the subsystem cannot be used concurrently. Improving this currently in progress. Metadata on the website not easily found. Currently, it's difficult to find the most important entities published on the website. And search engines cannot find the website either. It's necessary to use search engine optimization tools. To achieve this, the following tools should be used. HTML improvements use the schema.org dictionary, keyword optimization, and linking to external reference. This is also a form of semantic publishing. The schema.org dictionary can be used to describe our data, and this can be placed the source code of the website and in JSON-LD format. The metadata can be downloaded from central meta-information system available in Excel or HTML tables. However, on the website, only selected classification elements are available for download. Unfortunately, there is no option to download the data various exchange formats. One form of semantic publication to make RDFs available as downloadable files on the website. In the central meta-information system, entities have validity periods, and various versions are stored in the Oracle database. An essential step in search engine optimization to link external reference our data, such as Wikipedia and Wikidata links, which not only support ranking but also direct users to additional relevant content. This step greatly contributes to contextualizing our data and aiding interpretation. If many people also refer to our websites, it helps with ranking and builds trust on our website, ensuring the users receive reliable content. In the central meta-information system and database, the functionality to link to individual entities is currently only available in the concept model you can see in the screen. Next image, we can see how we can generate RDF from relational database. Finally, examine the cost of producing metadata. The current cost of metadata production is high because metadata reuse across different domains does not always occur. By implementing linked open data architecture using URI, making data accessible, and defining relationship between different versions, we support data reuse and operate most cost effectively. Disadvantage is decentralized operation and many users creating metadata control is not resolved through IT means. The FAIR principles also articulate the principle of rich metadata description. It is usefulness, the describing our data with metadata time-consuming tests, but it greatly improves the quality of our data. In the central meta-information system, we have the opportunity to link our data and describe them with various entity types. Few words about development. What is a rule? Development should be done within a project team comprising diverse experts. Supervision of operations should be centralized. Training and consultancy should be provided to stakeholders. Efforts should be made to promote the use of metadata. Semantic web technology has slower conquering world than we hoped 20 years ago. The problem lies in the quality of published dataset, the scarcity of experts, and weak technology support. It's crucial when publish our metadata according to linked open data principles and use existing dictionary when publishing or at least align our metadata with these dictionaries. If the office decides to develop the current system and utilize load technology, the development should include connecting data sources to concept, linking concept to each other, linking code lists to concepts, and so on. Furthermore, the implement the FAIR principles is necessary to create a code list for Creative Commons values and address connection with external registries using interface. Biggest challenge for both semantic technology and office is ensuring compliance with artificial intelligence developments. It can be beneficial for both external and internal users to create, for example, chatbot for interprets RDF triplets that also use verified international dictionaries and can provide data context with quality attributes. Okay. Thank you so much.
Thank you very much, Anikó, and thank you very much also for sticking to time. So there's a lot of information there. So please think about your questions for Anikó about when we come to the discussion. Our next speaker is Konstantin Laikam, who is chair of the Interstate Statistical Committee of the Commonwealth of Independent States, CIS-STAT. He has a doctorate in economics and a doctorate in IT, 2 doctors. He led the development of statistical methodology and information systems for statistics, and currently is leading the development of a data hub on statistical data and metadata in the CIS. And he will talk to, so this, that we started off the session, I should have said this, with 2 long papers, and now we have two shorter papers. So Konstantin will have 10 minutes, and he'll talk to us about FAIR statistics, semantically rich development for linked open statistical data creation and interpretation. The floor is yours.
Yeah. Thank you very much for my presentation. Dear colleagues, the Stat Committee of CIS, CIS is Commonwealth of Independent States, is an international statistical organization. Almost its main function, it is important to highlight, first, the collection of data from national statistical services of CIS countries. Second, summarizing data for the Commonwealth. And third, the publication of statistical data and metadata for the countries and for the CIS in general. Therefore, the issues of statistical terminology and methodology, harmonization, comparability of statistical data across countries, and accordingly formation and dissemination of high-quality metadata is very relevant for our organization. SDMX is commonly used for metadata dissemination. However, the analysis of its implementation shows that there are still some challenges. First, SDMX object model doesn't support the entire variety of relationships between metadata entities. Extended metadata ESMS is optional, quite complex to complete, and therefore often not used at all. Brief metadata, DSD, describes only the structure and encoding the data of data sets. Third, metadata is usually distributed separately from data. Do you know it? The implementation of lot principles proposed by the UNC high-level group on the modernization of official statistic would address these challenges. Loss data hubs, commonly based on RDF data cube vocabulary, combine the benefits of SDMX and linked data. Our experience in creating semantic models in statistics proves that the success of this work is crucially influenced by the quality of methodology description, focused above all on terminology, as well as on the richness of semantic connections. Poor semantics of the basic models ensures the compliance with the standards, but does not realize all the potential of semantic web and doesn't not guarantee an ambiguous machine interpretation and clear human understanding of data. Considering the international and our own experience, CSStat realized the idea of building a semantically rich interpretation environment with the aim to improve the quality of statistical data and metadata, to harmonize statistical terminology and align methodology, to comply with FAIR principles, to provide semantic interoperability and reuse, and facilitate metadata relevant interpretation. Due to this approach, we've got the following benefits. Developed semantic models in statistics, generated smart metadata, semantically rich lot sets, expert validation of results using visualization tools. To achieve these goals and benefits, we focused on the following objectives listed on this slide. To form the methodological and terminological basis for constructing smart metadata and preparing lost in our data hub, to provide collaboration tools for experts, statisticians, and IT specialized, supporting harmonization of statistical terminology and alignment of classifications, to implement the technology for describing statistical indicators, to generate smart metadata based on this description and semantically enrich of corresponding lot sets, to ensure the cataloging and dissemination lots set and semantic assessed such as core vocabulary, glossaries, controlled vocabularies, and to support the consistently validation of developing smart metadata and lot sets and semantically rich interpretation environment. To meet these objectives, two systems have been specially created in our data hub. They are the semantic knowledge management system and a system for lost preparation and dissemination. Those two systems provide a single, consistent terminological and methodological framework for the development of rich semantic models used for lost and smart metadata. It's open for external customers and integrated with our data warehouse and our business intelligence analytical system. This slide represents the general logic of this system's operation cycle, as well as the main platform, standards, and tools used for the realization. Labor statistic is the first domain used for this system's evaluation. Its digital library already consists of more than 80 documents, methodological documents. Half of them are structured and published on XWiki pages using hypertext markup, linking glossary terms and related documents. It should be noticed that for the first time in CIS countries, 32 lot sets were developed and equipped with smart metadata available for 10 statistical indicators. By the end of the year, we are planning to add 7 more domains. So, as a result of this work, an environmental of meaningful interpretation of smart metadata and loss has been created and provided to the customers. The developed data and metadata meet FAIR principles as detailed in this table. It confirms the feasibility of the ideas stated in the Smart Metadata Manifesto. Moreover, we have realized the end-to-end technology for the generation of smart metadata and loss. It covers all 7 stages of the operating cycle presented on the earlier slide. Starting with the formalized description of methodological and guidance documents in statistics, then going through the terminology harmonization, classification, alignment, resulting in the development of semantic models, finishing with the creation and dissemination of loss sets with rich semantics supported by the procedures of the visualization and validation. Yeah. Yeah. And, no, our R&D team is ready to answer all possible questions, and I would say we are open and we're interested in our cooperation. Thank you very much.
Thank you very much, Konstantin. So, last but by no means least, the 4th speaker in the session is Alina Danciu. She's a team leader at Sciences Po at the Center for Socio-Political Data. She is a DDI metadata specialist and a member of the European DDI Conference Programme Committee. And she would like, in that context, to remind you that you're all welcome in Chur, Switzerland, in December 2024, which is the next European DDI users meeting.
Yeah, please come. Thank you, Simon, for the introduction, and thank you, Insee, for organizing such a great conference on smart metadata. I'm not used to see conferences on metadata in the official statistic world, and I'm so happy to see this and to be here. And I'm waiting for the 2nd and 3rd edition. I'll try to be quick. I don't have a lot of slides, so I think I'll have less than 10 minutes. So I speak to you today about the importance of FAIR DDI-compliant metadata in optimizing reuse and preservation in social sciences research data. I come from the research data world, from a small data archive that has been sharing research data for almost 20 years now, 20 years next year. We have 19 years now. And I have, I'm going back, I have prepared this paper with Nicolas Auger, who is in the room. And so at the CDSP, really quickly, we have around 400 databases, mainly on political attitudes, but also gender, family, migration, school. If you want to work on French election results, you'll come to us, at least until the results until 2012. We were among the first French archives to adopt DDI, that was mentioned several times during this conference. So the DDI suite can document and manage different stages in the research data lifecycle, such as conceptualization, collection, processing, distribution, discovery, and archiving. We proudly use the FAIR principles all along the data lifecycle, and we mainly use 2 DDI products, Codebook. Erfan described it yesterday, but I'll remind it just in case. It's one of the products that is used to document mostly simple survey data, and you cannot reuse. For us, it is suitable for all the studies that are single studies that are not longitudinal. We also have longitudinal data, as we have the French ellipse, longitudinal probabilistic ellipse panel. And for that, we began an experimentation with DDI lifecycle, who is more suitable for such data. we have an active role in supporting DDI use in France. Once again with Erfan and Simon, here we were the ones to provide I think it was the first online DDI training in France. The year is not correct. It was 2 years after. I'll correct that. So we respect the FAIR principles all along the data life cycle, and we had the core trust seal last year, and we are really proud of that. So FAIR principles, one of the very important aspects in being eligible for the FAIR principles, for being eligible for the core trust seal, is the respect of those principles. And what I would like to talk about in the next slides, we believe with Nicola that if the first 3 FAIR criteria are now widely explored by the research data community, the R principle is much less so. So we wanted to ask ourselves how to make data, the CDSP of course, but in general also reusable once it is findable, accessible, and interoperable. I would like to remind you the GoFair recommendations that I won't read. I think you all know them. And what I would like to, I won't dare to say what's missing, but I could. What I'd like to discuss is data quality that I think should be considered more in the FAIR principles. So respecting an internationally accepted metadata schema for metadata along with quality criteria for metadata and data are key elements, of course, for both reuse and preservation. And what do we mean by data quality? The CDSP, I'll just give you our example because that's the easiest thing to do. We accept data that have demonstrated their importance to the social science community through their substantial research value and or teaching value, and their legacy value or uniqueness. I'm not sure that this is enough when speaking about data quality, so we need more formal criteria when it comes to data quality, which would make it possible to prejudge the reproducibility and the reuse of data. It would make it easier. We also think efforts should be made. Once again, I'm speaking about us, but this could be a general remark also, that efforts need to be made in terms of metadata describing the origin and processing of data, and also when it comes to publishing codes and algorithms. We don't do it enough. And I told you I would be quick. So to sum up what I just said, and I would like very much to hear your opinion on this. So that's why I'm so short, because I wanted us to have more time for discussions. To move on, I think to be even more fair, we need more formal data criteria. We should publish more codes and algorithms. We should also take into consideration the description of larger and cultural context of data collection. To give you just an example, in studies like CSES, comparative study of electoral systems, or in the ESS with the media claims that is done. And we should also explore, why not, new standards, such as the structured data transformation language for representing data transformation commands. So this is my conclusion, and I very much look forward to hearing your questions, comments, and suggestions. And please get in touch with us if you have really specific questions after for us. Thank you.
Thank you, Alina. And that was a nice way you took less time than you needed to, but that was a nice way to end that series of presentations with a set of questions. I really very much hope that that will stimulate discussion. Are there any questions from the audience? Please raise your hand, don't be shy. I think people are going, and I will step in if necessary.
Yes, I have a question for Olav. What is the added value of the FAIR digital object compared with the DOI?
Yeah, okay, the FAIR digital object. I heard about it 2 years ago. I went to a conference in Leiden. We had a paper together explaining about what we do in official statistics. I went to this conference. I tried to understand all the concepts there. And I looked at it again when writing this paper. In between, I thought, I questioned myself, how far did this FDO community progress? And I didn't see too much progress, I must say. And in the paper, I wrote down my conclusion that the FDOs are not implementable for us at this moment. It's still developing. And then I thought, but I've taken this knowledge, maybe there are some ideas and principles that we can apply in the official statistics world. And that were exactly the two on my last slide. And that's the idea that the way you identify your artifacts maybe doesn't matter so much, but they have this principle that it has to be identifiable in a kind of a PID system. So that was my thinking, that whether we use DOIs for publications or articles or press releases or scientific papers or on the data level, or we use URIs or URLs or URNs or whatever, in the end, it's better to make it all compatible, as there was the previous discussion. But if it's not doable, then at least we can have this thinking about what's our PID system, like the FDO, what's the concept of identifiability for all the artifacts in official statistics. So that was my thinking, and your question was more detailed, but I hope it answers a bit what I thought.
Maybe I can jump on that. You said in your presentation that it could be an intriguing idea to have a universal PID system for official statistics and for the various entities. Yep. Do you have any suggestion about what that would be?
No, that would be too ambitious for this paper, I would say. But exactly that discussion is going on in the FDO community. And therefore it's maybe so difficult to progress, because if you have all been in favor for a certain flavor of doing, like generally speaking, in a kind of architectural decision, you have about very generic designing universal identifiers. You can do it centrally, decentrally. You have so many systems of doing this. DOI is only one of the biggest right now, but there have been many. Maybe this kind of discussions are also something to have in our joint communities.
Okay, thank you. Would any of the other panelists like to add to that discussion of FDOs and identifiers? Is that something that you're using in your systems? And if so, how are you? Not
yet, but we have a grant with about the NACE, and we try to determine the URI for our NACE element, and try to make the PID, and yes.
Okay, thank you. Any more questions from the audience? Right, there's a whole load there. Frank, I saw his hand go up.
Yeah. My question is also for Olav. So it's about your software point of view, and it's about the R in FAIR, so the reusability of software between official statistics office. Because we have this awesome list, which is awesome. We have published, I don't know, lots of programs, open source programs. Only talking about the Insee, we have like dozens of open source programs on GitHub. and very good ones in some cases, and very useful ones in some cases also. And yet, and we also had actually projects at the European level for fostering reusability, or reuse at least, of software. And most of those programs have been total failures. I can say that because I was leading them. So, so what's missing here for the reusability of software?
Well, you're in happy company. I'm also project manager of failing projects, therefore I'm in this metadata conference. Now, I'm joking, and you're joking as well, because I know a few of your open source projects that are really, they're also on the list, isn't it? With all these subjects, I don't have the solution. I'm kind of an observer, and I really, if I think I have some knowledge, I want to share it, and that's the way that this list started. Talking about successful open source projects versus the ones that don't make it, in many cases, in European projects, if it goes, well, let me put it this way, if it goes like this, you have been working together, you have deliverables, and somewhere in the grant agreement it was also stated that it had to be open source. You choose a license, and at the end of the project you put all the software in a zip, and you put it on GitHub, then you are pretty sure that no one is going to use it. That's not the way. It's very difficult, actually, to do it in such a way that the chance is as high as possible that people can reuse it. And one of the things that we found out to do is to start making it open as early as possible if you create something. But because only then people can think with you about the right direction. They can see maybe the added value of something they did and say, oh, maybe you can put your functionality that I already have implemented in your software, and then we work together or something. And this is another thing I see many times is that in international projects, let's say young data scientists have to fight a barrier of management who are scared about making their products open source because they think, oh, what if someone is going to use our stuff? In reality, if you make it software open source, in 90% of the cases, nobody's going to use it because you have to work hard to make your software so good and so well known to let it use. So it's a long answer again. My experience is look at the successful examples where people have worked for, and it's not choosing a license and putting it somewhere. It's giving presentations, explaining about the functionality, keeping it going. Because if it's a one-time project and then it dies, the software, then you are happy if someone wants to take it over. So look at the good experiences, I would say. And you have also very good experiences, I would say.
Thank you. I think Merce was indicating that you wanted to come in, yes? Well, I strongly suspect that you have something to say on this topic.
Well, first, just a clarification also, because I think there is a limit to the how far the FAIR principles, what they are about, right? And then there is a lot that needs to happen after that. So first of all, that for reusability, one thing is enable reusability, enable interoperability. And so the first step is, like you said, you have to have either for data license, or for software, a software license. That's what the principle is about, right? That you specify in your metadata and in a way that it is accessible, how that object can be reused. That's the first step. But there is the fact that then it gets reused. In some ways it's a social science problem, right? It's something that requires many other factors to make that happen, and a community around it, and some way, making it sustainable. And so I just was thinking about that, because also the reusability came in the other presentation, right? And I think it's great to have the FAIR principles, but one thing is doing this, enable findability, accessibility, interoperability, and reusability. The other is making it happen. And I think that requires a lot of other thoughts that are beyond the FAIR principles, and that's fine, but we need to think of what the community needs to do to actually reuse that. And just wanted.
Thank you, Mercer. I actually thought you were going to say a comment about on the software perspective from the Dataverse perspective, but that's a really nice transition.
It could be an example because we had done studies about how open source, the sustainability of open source software and what it takes to make open source software successful, successful in the sense of healthy and being reused. But it was a study that included many different areas of research. I mean, of the government, having the right governance, building the community, for the different levels of maturity. I just mean that it's a whole area of work and research to help, that it's way beyond the FAIR principles, but very important to make that happen.
Yeah. But I also, in what you said, I thought there was a transition to, I want to make sure that we leave enough time to take on Alina's challenge of discussing, okay, that gap in the FAIR principles, and particularly ideas of data quality, and you also highlighted provenance or lineage and process. You said in your talk, we need more formal data criteria. Please unpack that for us, and then perhaps we can take some questions. What sort of criteria?
It was kind of a question I had also for you, because I listed those we have now that are so general. I mean, for us, when researchers come with their data, we are data engineers. We won't judge their research. It's not our role. What we'll do is that we'll look at the data, see if it's complete, how the missing values are in the data set. We'll also try to judge the reusability of the data set, because that's a criteria for us to share or not. We'll spend a lot of time documenting that, so it's a criteria. So it's things like that. But I think we should go move on and try to have more things like what you said, provenance, lineage. We don't have those for the time being. So that's, I was hoping to hear more from the audience and what you do
Yeah. Thank you, Alina. Do we have any questions on this particular topic? There's a loads. There's Georgi and there's someone behind. Colleagues, please step forward with the mic when you. And yeah, please.
Sorry, it was not about this point.
Okay.
I already had a question for Alina, so it's a different one. Is it still okay?
Yeah. Go ahead.
Yeah.
Go ahead.
So I actually had a question about this last slide when you talk about the publication of codes and algorithm. And I wonder if you already have some initial thoughts and the idea about this area, given all the experiences, much richer and much more like intensive knowledge and the collaboration that done on the data and metadata side. Because in terms of like a model, which is maybe algorithm plus data, there are some rudimentary work, but I think documentation and publication of
models and the algorithm is still far behind compared to the data. So I wanted to hear your thoughts. I totally agree, and even in our case, we are beginning to do it, but we are so far behind. And yeah, we should do it, and I think we should all do it, and consider this data as data. I hope it answers your question.
I mean, I think that was a resounding yes, that would be really important. Yeah, do you want to sort of say anything more about how? I mean, how would the FAIR principles be applied to algorithms?
I have no idea, to be honest.
Yeah. Yeah. So a topic for further discussion. Let's take the question here, please.
Yeah, I just wanted to chip in with some quality criteria that in the OECD, at least internally, we have a quality assurance program for the statistical work that we do, and we do regular reviews on various domains. And we have a number of additional quality criteria that we try to poke into and probe. So some of them are, well, relevance. Your criteria is kind of an implicit relevance criterion, but then beyond that we look at the accuracy of the data, so whether it measures what it claims to measure and how precisely it does. We also have criteria on timeliness, and sometimes for archival data and historical studies that's not so relevant, but in our context of monitoring economies and developing policies, timeliness is quite a relevant criterion, and we try to look at our processes around statistical production to get timeliness and improve it. And then we have credibility, coherence of data, so if we look at the data in context and how it relates to other data. And then of course we have accessibility and interpretability and interoperability and the rest of the FAIR principles.
Thank you so
I'm
much.
happy to share some of the documentation we might have around this framework.
Yeah. That would be very interesting, Yuri. Can I just ask you a question on that? How do you apply those criteria? So you've got those criteria. How do you apply those? Do you give the sets a grade, or are these sort of barriers, as it were, that a given data set, given data source would have to reach before you make it available? How do you apply them?
At this moment, we have regular reviews, kind of on a rolling basis. 5 to 10 years, every statistical area undergoes a quality assurance review. But we see it as too soft of an approach to quality assurance. What we try to do forward-looking is to put into our systems, or try to make many of the criterions testable as part of our software and applications, and regularly monitor their state as far as it's measurable. Sometimes these criterions are assessed by humans in some sort of an overall sense, without precise kind of meta measurement on the quality. Yeah. But yeah, there's a long way to go to make them more.
I have to say, I think this is a really important issue, and it's not just in official statistics. Colleagues, for example, in crystallography talk to us a lot about these sort of issues and have problems or an issue with. The FAIR principles didn't set out to talk about quality, and that's fair enough, if you'll pardon the pun. But we do need to talk about quality as well in the various components. Okay, I got the 5-minute warning about a minute ago, so if you have any questions that you want to ask before we go to lunch, please raise your hands so we can fit those in. I saw one down here on the left, on my left, you.
Thank you. I'm talking about data, more than metadata, talking about microdata in particular for the official statistics. I work for the ILO. At the ILO, we have a huge repository of microdata of labor force surveys in particular that we use to calculate and publish harmonized indicators about the labor statistics. But the big problem is that we have a very good number of countries giving us the microdata, but only for the purpose of our own use, and we cannot share that with any researcher, any other institution, even those that don't recognize institutions. We have an agreement, and most of the countries give us the data just for our internal use. And there are even some countries that do not share the microdata. That is the official source of information where they compute their official statistics from. So my question is there anything that the scientific community can do in this regard to help to make the microdata more open and accessible?
That's an excellent question, and I'll hand it straight over to the panelists. Please, how would you How would you answer that?
In the next session, you'll have a talk about this from the French Center of. So I forgot his name. That's shameful of me. The French Center for Access at Secure Data. I know it in French. Is it Halima? Did I say it right? So she's going to speak about that.
I'm not talking about European countries, of course. I'm talking about the rest of the world. I mean, in Europe, in general, microdata access is guaranteed through Eurostat, but it's not always the case for national surveys. For the Euro survey, it is. But the problem is that there are many countries in the rest of the world that only gives the data for particular purpose under a special agreement, and this is not open data.
So does someone from the panel want to come in? I think maybe Olav was...
Yeah, very roughly thinking. So the ILO microdata that you got from all the countries has the added value that you see the big picture over countries hang. So the country-specific microdata, if there's access, the researcher has a limited view on what happens. So that would be the big use case to go on, say, and put pressure on agreement, whatever, so that you have this facility for microdata study at the ILO level. So that would be my thinking, to go that direction.
I can see that George wants to come in.
So I think the model for this is the IPMS project at Minnesota, where they've got something like 100 countries now where they've got microdata. And the way that actually started, and I think a lot of the success, was that they had a person who went to these countries to negotiate with each agency that had data. So it's really not a problem of science, it's a problem of diplomacy. And I have often thought that IPMS is probably the only really successful foreign policy in the United States for the last couple of decades. So, but I think that that's what it takes. It takes an ambassador from the central agency to go to these countries and learn what they need and speak to them individually.
I think we have wrapped up. We've hit time there. I think it's a very good point to close on, that we need science and data diplomacy in order to get access, to maximize access to microdata. And maybe some of the colleagues on the panel could discuss that further over lunch. Thank you very much to the speakers. Thank you very much to the questions.
Before people go, quick housekeeping things. First, lunch is in the cafeteria upstairs. Go out to reception.